Hello everyone. Today we'll be looking at some quick solutions to the chemistry section of All India AIATS Test Series JEE Advanced 2019 Test 4A Paper 1 Code A and B. So let's start with the first section. This section contains 5 questions. Each question has 4 options out of which only one single option is correct. So let's start with question number 21. A gas mixture has propane and butane. At STP, 15.68 liters of CO2 is produced when the mixture is completely oxidized by excess of oxygen. If only propane is oxidized, then the CO2 produced consumes 1 liter of 0.6 molar KOH for complete neutralization. So the examiner is interested in the mass percentage of butane in the mixture. So let us figure out the data which is given to us. So we have been given that when the mixture is oxidized, there is a formation of 15.68 liters of CO2. So 15.68 liters at STP. So we can find out the moles. So we can say that the number of moles of CO2 which is produced is equal to 15.68 upon 22.4. So this on simplification gives us a number of 0.7. So the total CO2 which is produced is 0.7 mole. Now it is further given to us that if only propane is oxidized, then the CO2 produced will consume 1 liter of 0.6 molar KOH for complete neutralization. Now we can say that the MEQ of CO2 coming from propane, it shall be equal to the MEQ of KOH. So it is given to us that the volume is 1 liter and the concentration is 0.6 molar. Now the N factor is equal to 1. So we can probably assume that the number of moles of CO2 coming from propane is equal to N, and the N factor of CO2 has an N factor equal to 2 when it is acting as an acid. So from here we can find out the value of number of moles of CO2. So that comes out to be equal to 0.3. So students, from the combustion of propane, which is C3H8, we have the formation of 0.3 moles of CO2. So this must mean that there are 0.1 mole of propane, as 1 mole of propane has 3 mole of carbon. So similarly we can find out that the combustion of butane produces 0.4 mole of CO2, as the total number of moles of CO2 was equal to 0.7 and 0.3 moles are coming from propane. So 0.4 must be coming from butane. By similar analysis, we can say that the amount of butane in the mixture is also equal to 0.1 mole itself, as 1 mole of butane contains 4 mole of carbon atoms. So in the mixture we have 0.1 mole of propane as well as 0.1 mole of butane. And if we talk about the mass, the molar mass of propane is 44, whereas the molar mass of butane is 58. So we can see that the mixture contains 4.4 grams of propane and 5.8 grams of butane. And the examiner is interested in the mass percentage of butane. So that will be 5.8 divided by the sum of these two values, which comes out to be 10.2 into 100. So students, this percentage will come out to be a little less than 58%. Students, we have to select option B as the correct answer to question number 21. Let us look at the next question. Question number 22. A compound exists both as a monomer as well as a dimer in the gaseous phase. The molar mass of X is 30 gram per mole. If 1 mole of X2 is taken in a fixed volume container of 13.84 liter at 27 degrees C, and the equilibrium X2 dissociates into 2X is attained with an equilibrium constant value of equal to 32 by 9. It is further given to us that the equilibrium mixture contains 50% by mass of X. So the examiner is interested in the incorrect statement among the 4 statements which are given to us. So let us try and solve this question. So we have been given that X2, it dissociates into 2X. Now at T equal to 0, we have started with only 1 mole of X2 where X is not present. And if we talk about equilibrium, we can assume that alpha amount of X2 has dissociated, which will lead to the formation of 2 alpha amount of X. Now it is given to us that at equilibrium, the mass percentage of X is equal to 50%, which means that the grams of X2 should be equal to the grams of X at equilibrium. So we can say that 1 minus alpha, which is the moles of X2, into its molar mass. The molar mass of X2 will come out to be equal to 60. It should be equal to 2 alpha, which are the moles of X, into the molar mass of X, which is 30. So we can say that 1 minus alpha is equal to alpha, which implies that the value of alpha is equal to half. Now the examiner seems to be interested in the pressure of the system. He is interested in the degree of the dissociation. So students, we have an equilibrium mixture in which X2 has half mole, whereas X has 1 mole. So we can talk about the molar mass of the equilibrium mixture. So M effective, it shall be equal to 60 into half plus 30 into 1 upon 3 by 2. So this comes out to be equal to 60 upon 3 into 2, which is equal to 40. If you look at the options now, option A says the pressure of system increases from starting to the equilibrium position. So students, this statement is correct. We can see that due to dissociation of X2 into 2X, the number of gaseous moles is increasing, which must mean that the pressure will increase in the system. So the first statement is correct. If you look at the second option now, degree of dissociation of X2 is 50% approx. So we had seen that the value of alpha is equal to half, so which will convert to 50%. So the second statement is also correct. The examiner seems to be interested in the pressure at equilibrium. So students, we can use the ideal gas equation in this case. So we have PV equal to nRT. So at equilibrium, the number of moles is known to us. The temperature is given to us. It's 300 Kelvin. The value of R is also known to us. And the volume is also given to us, which is 13.84. So we can put all of these values. So we have P into 13.84. It should be equal to, so total moles are 3 by 2 into R. The value of T is equal to 300 Kelvin. So if we solve this expression for the value of P, we'll get the value of P as 8 by 3. So students, the third statement is also correct. And if you look at the fourth option, the molar mass of equilibrium mixture is 45 gram. This statement is incorrect, students. We had just seen that the molar mass came out to be equal to 40 gram per mole and not 45 gram per mole. So in this question, we have to select the incorrect statement. So we have to mark option D. Let us look at the next question. Question number 23. 1 mole of an ideal monoatomic gas is subjected to a cyclic process connecting the states A, B and C. As shown in the temperature pressure diagram, the line AC passes through the origin while AB and BC are parallel to the temperature and the pressure axis respectively. If process is reversible, then the total work done of process ABCA is. So students, we have been given a T versus P graph and the examiner seems to be interested in the total work done in the process. So if we look very carefully at the graph which is given to us, we can clearly see that the path from C to A, it is a straight line which passes through the origin. So it must mean that the path C to A is isochoric, which means that the work will be 0 in this case. If we look at the path A to B, this process is happening at a constant pressure of 2 atmosphere. So this path is isobaric. And if we look at the path from B to C, the process happens at a constant temperature of 300 Kelvin. So this path is isothermal. Now if we try and figure out the state, so we have been given the number of moles and we have the value of temperature and the pressure. So we can find out the value of volume. So the volume at A can be given by nRT by P, and on putting the values, N is equal to 1, the value of R is 0.082, the value of temperature here is 600 Kelvin and the value of pressure is 2 atmosphere. So this volume will come out to be equal to 24.6 liters. So which will also be the volume at C. So VC is also equal to 24.6 liters. Now if we talk about VB, the value of volume at B can be calculated by the fact that the pressure is constant and at constant pressure the temperature has been made half times, which means that the volume will also become half times the initial value. So the volume at this point shall be equal to 24.6 upon 2, which will give us a value of 12.3 liters. Now, if we talk about the paths AB, the path AB is isobaric compression. We can see that the volume initially was 24.6 liters, now it is 12.3 liters. So, the path from A to B is isobaric compression. And if we talk about the path from B to C, so from B to C, there is expansion happening. So, this is isothermal expansion. So students, we know that during compression, work is done on the gas and it is taken to be positive. And during expansion, work is done by the gas, which is taken to be negative as per the conventions. So if we talk about the work done from A to B, path A to B is isobaric compression. So the work will be positive as it is compression. We had already seen before. So it will be given by P into delta V. So the value of pressure is kept constant. It is equal to 2 atmosphere into delta V. So the volume initially was 24.6, now it is 12.3. So there is a difference in volume of 12.3 liters. So which comes out to be equal to 24.6 atmosphere liters. So this is the work done in path AB. Now if we talk about the work done in BC. So the path BC was isothermal expansion. So work will be done by the gas. So nRT ln V2 by V1. The value of N is 1, R is 0.082. Temperature is kept constant at 300 Kelvin. And the volume is doubled. It goes from a value of 12.3 to 24.6. So ln2. So this on simplification, there will be a minus sign also. So this on simplification will give us a value of approximately minus 17.04 atmosphere liters. And if we talk about the work done from C to A, we've already seen that the work done from C to A shall be equal to 0 as it is an isochoric process. So if we talk about the total work done, so total work shall be equal to 24.6 minus 17.04 in liter atmosphere. So this shall be equal to approximately 7.56 atmosphere liter. And the total work shall be positive. And if this is converted into joules, so we have to multiply it by 101.3. So it will approximately come out to be equal to 764 joules. Students, we can see that the correct answer to this question is given in option C. Let us look at question number 24 now. So question number 24. An organic compound P has the formula C8H10. Select the correct IUPAC name of that isomer of P which contain benzene ring and has highest reactivity in the electrophilic substitution reaction with a mixture of concentrated H2SO4 and concentrated nitric acid. So students, the examiner seems to be interested in the benzenoid isomers of this formula C8H10. If we talk about the DU, C8H10 has a DU equal to 4, which means that all the DU has been consumed in the benzene ring itself. So we can have xylenes. So we can have the orthoxylene, we can have the metaxylene, and we can have the paraxylene as well. And in addition to the xylenes, we can also have ethyl benzene. So these are the 4 benzene based isomers of the hydrocarbon P. Now if we talk about the reactivity towards electrophilic substitution reaction with a nitrating mixture, students, we know that the metaxylene has the greatest reactivity among them as the plus H exerted by both these groups have a consolidating effect at the 3 positions which are mentioned in the diagram. So metaxylene will have the greatest reactivity. And students, if we talk about the IUPAC name of this metaxylene, it is called as 1,3 dimethylbenzene, which is given correctly in option A. So students, we have to select option A as the correct answer to question number 24. Let us look at the next question. Question number 25. The total number of structural isomers of compound C5H10 that on oxidative ozonolysis can produce CO2 gas is. So students, if we talk about C5H10, we can see that it has a DU equal to 1. So there is only one double bond present inside the structure. Now if we talk about the alkenes which produce CO2 upon oxidative ozonolysis, so we can see that it has to be a terminal alkene, as only terminal alkene will first form formaldehyde which can be further oxidized to CO2. So if we talk about the terminal alkenes, we can probably take out a CH2 group apart and we're going to have C4H8 left. So the C4H8, we can have all the remaining 4 carbons in a straight chain. And if we talk about the attachment of double bond CH2, so we can have the attachment of double bond CH2 at any of these 2 positions. So there are a total of 2 different positions possible for this straight chain hydrocarbon, and we can have double bond CH2 attached at any of them. So we're going to have 2 isomers present here. We can also draw them if you want. So in one structure, the double bond CH2 will be at the terminal position, whereas in the other structure it will be at the non-terminal positions. So both these alkenes on oxidative ozonolysis are going to produce CO2 from the circle carbon. Now we can also have a shortening of the main chain. So we had 4 carbons left if we took out the CH2 group. Now these 4 carbons were first arranged in a straight chain. Now we can have a branching as well. So we can have a main chain of isobutane. And now if we talk about the different positions possible where we can attach the double bond CH2, so there is only one single position. All these 3 underlying positions are identical and we can attach a CH2 group at any of these carbons to obtain this isomer. So this will also lead to the formation of CO2 and oxidative ozonolysis. So we have a total of 2 plus 1 which is equal to 3. So students, we have to mark option B as the correct answer to this question.